This is Innovledia.
Hello and welcome back. In this video, I'm going to show you how to do an image-based lighting using an HDRI and use the physical sky system in Maya. Alright? The full form of HDRI is High Dynamic Range Imaging. An HDR image is a 360-degree image or photograph of a place with a lot of color information that is wrapped on a sphere in a 3D space to simulate a real-life lighting condition. You will understand it once I demonstrate its use inside of Maya. Alright? Now, the first thing that you have to do is go to Arnold menu, then Lights, and click on Skydome Light. This will create one giant sphere around our objects, which is our Skydome light. You have to dolly out to be able to see it. This is extremely big, and you can scale it up or down if needed. This is a kind of light that uses a spherical shape to emit light from all the direction and illuminate everything that is inside this sphere. Hence, it creates a global illumination within your scene. Generally, it has a color and intensity attribute like all the other lights. You can change its intensity and use this light for global illumination. You can either choose the color of light, which is white by default and looks quite better this way, or you can choose an HDR image to use it as an input for the color attribute of this light. Let me show you how to do it. Instead of moving this slider or clicking on this box, you have to click on this checkered box here to the right of this slider, and then it will ask you to create a new render node where you can actually choose the kind of input that you want to plug in to the color attribute of light. As I want to use an HDR image, so I can click on this file option here. This will create a new file node which will allow you to select any image file on your computer that is supported in Maya. Let me first rename this file node. Always make sure that you rename everything you create. Otherwise, you may not be able to identify anything in the end. Now, we just have to click on this folder icon to select the HDR image which is located in the source images folder of our current project, and click on Open to load the file. Now, if I just dolly out, you will see that the HDR image has been wrapped on this sphere and is being used as a source of light. All the bright highlights, such as the sun on the image, is used to emit light in such a manner as if our objects are really within this environment that you see within the HDR image. So, you will find these shadows forming according to the position of the light source in the image. Not just that, the environment will be reflected on the objects that have reflective materials, and this environment will also be visible to the camera as a background. We can even rotate the Skydome light to change the direction of light coming from this HDRI, and hence the shadows that form as a result. Here, within the attribute editor, you will find an option to enter the resolution of the HDR image in pixels that you are using. And you have to enter the size of the largest dimension, which is usually the width of the image. In my case, this HDR image has a size of 4096 pixels wide by 2048 pixels tall. So, I can keep it to 4000. I would have entered 2000 if the size was around 2000 pixels wide, alright? I can increase the exposure of the light if I want to, but I think it is already bright enough. So instead, I am going to reduce the intensity to 0.8 so that the highlights don't appear overexposed. I can also increase the samples to reduce the noise from the shadows. And below all of these common attributes, we have this visibility section, where we can set whether the Skydome light will be visible to the camera or in transmission or in diffuse, and so on. you can turn the visibility to 0 for the camera if you don't want the Skydome light or the HDRI to be visible directly through the camera. You would have to deselect the Skydome light here to see the effect. Alright? If you turn this diffuse attribute to 0, no light will bounce from the surfaces of objects, and hence everything will appear colorless and dark. Now, you might think that if there is no bouncing of light from the surfaces, then how come we are still able to see these objects? They should all become invisible, right? Yes, definitely. But in a standard material, the surface color and the highlights are controlled by two separate attributes. One is diffuse, which is the base color that controls the appearance of surface, and another is specular, that controls the appearance of these highlights and reflections. So, if I turn this specular attribute to 0 as well, then the Skydome light will not be visible in reflections, as well as stop creating the highlights, because of which the Skydome light will have no impact in illuminating our scene, and hence the scene will become completely dark. Alright? Same way, the transmission will decide whether or not the Skydome light will be visible through transparent objects. And just keep this in mind that if the Skydome light is not visible in any of these components, then the HDRI will not be visible as well, because both are linked together. Lastly, if you wish to change the HDR image, you can do it by selecting the Skydome light and then going to the color attribute and clicking on this black icon here. This will take you to the same file node where you can select a new HDR image just like you did before. Once you have chosen a new file, it will update on the Skydome light after few seconds. Alright? And if you are wondering where to find this type of HDR images, then you can visit this website polyheaven.com, where you will find free HDR images that you can use in your projects. However, always check the license before you use them in any commercial project. Alright? So, this was all about using the Skydome light and HDR image as a source of light. Now, coming to the physical sky, you have to go to Arnold menu, then Lights, and click on Physical Sky. This will create a Skydome light, but with a physical sky shader plugged in to the color attribute of the Skydome light. Physical sky is not actually a light in itself. It is a system or a shader that acts more like an image, and hence it needs the Skydome light to illuminate our scene. And to see it properly, you have to switch to the Arnold render view instead of this viewport rendering. Let me open it. You can go to its window menu and click on Frame All to fit the preview within this window, and click on this button to start and stop the preview. Okay? So, it is a system in which you can simulate an actual physical sky with a sun, where its direction and intensity can be changed. Alright? To access the attributes of the physical sky, you can select the Skydome light. Always remember that you can select the same from the outliner as well. Okay? So after selecting the Skydome, you can click on this black icon beside the color attribute, and that will take you to the attributes of the physical sky. Here, the first attribute is turbidity. It is used to set the amount of particles in the air, like that of dust, smoke, and others. This causes a shift in the color of the sky, from clear blue to dirty blue. You can increase the turbidity if you are creating a scene for a city, because the air is mostly polluted there, and also when there is a bad weather. Alright? The next attribute is ground albedo. It is the color that is reflected from the ground towards the sky, causing a shift in the color of the sky, You can change it according to the scene you are creating. Like if it is a grassland, you can change this to somewhat green. If it is a desert, you can change this to yellow or orange. If it is a place covered with snow, you can change this to white or light blue. I usually don't change it unless necessary. Next is elevation. It is used to change the angle of the sun from sunrise to sunset, and hence it has an angle ranging from 0 degrees to 180 degrees. The sun lies above the head at 90 degrees. You can take this value beyond 180 degrees, but that is totally meaningless because it will start looping. The azimuth is used to change the direction of the sun around the sky, and hence it has an angle ranging from 0 degrees to 360 degrees. Using this, you can actually set the direction from where the sun is rising and where it is setting. Alright? Then we have intensity, to increase the intensity of the sun. This will also increase the light in your scene as well as in the sky, like it should if it was a real sun. We can also change the color of the sky and the color of the sun if we want, by selecting any color from these tint attributes. These attributes are rarely needed because we hardly ever need to change the color of the sky or the sun, unless we are trying to achieve some artistic look. By changing the color of the sky, the light is not going to be affected that much. But by changing the color of the sun, the color of the light will change as well. The sun size will allow you to set the size of the sun, but that is again unnecessary because the sun within this physical sky doesn't look that original as our real sun. It doesn't have all that glow or anything, but just a circular shape filled with a single color. This is mainly useful in case the sun is reflected on a shiny surface. You can increase this to make the sun more highlighting or prominent on the surface. Lastly, this checkbox below is used to enable or disable the visibility of the sun in the sky, that whether or not you want the sun to be visible in the sky, and hence as a result there will be no formation of shadows due to the absence of direct light. This is particularly useful when you are creating a sky covered with clouds, or when the weather is cloudy and the sun is hidden. Alright? One more thing I would like to tell you, that you can increase the quality of the output by increasing the samples of the Skydome light. This will reduce the noise within the shadow areas. Alright? So, this is how we can do image-based lighting using an HDRI and use the physical sky system in Maya. See you in the next video.